So now we have just over half an hour of general discussion about this issue. I would like to introduce that debate with a few words. I'm not a member of ICRP. I'm not an authority, and I head a scientific institute which does research, including on environmental issues. And our mission is to contribute to protecting the public and the environment from radiation from a science perspective. And that's what I would like to say over a few words. First, I think in my mind at least, there is no reason, no valid reason why the three very wise principles which the ICRP has been promoted for decades should not be applied to the environment, that means to our ecosystems. There are other biotic systems, but these principles, I think nobody reasonably could question the applicability of these principles. Now, if you start from that end, Dr. Das' presentation was extremely interesting because it gave a precise societal expectation. What does it mean? It means sustainability of the ecosystem when you implant a new nuclear plant, for example, or any other industrial activity. The three principles should mean that there should be no effect on the durability, on the sustainability of the ecosystems concerned. So that's the end point. If you talk about risk evaluation, the end point is there for society. It is not the fish or the turtle, it is the ecosystem. Now, to address that, of course, we would like to prove in a planned exposure situation that there will be no effect. That's the ideal situation. And then the reasoning, if I understand well, is that, well, if the most radiosensitive elements of the ecosystem are not affected, well, you should expect that the whole will not be affected. Is this true? I think this needs science around it because it seems simple, but it might not be true. It might not be true for a number of reasons. One of them is because usually when changes are planned, it's not only radiation, it's other activities, other human activities, temperature, for example, in the case of a nuclear plant. And it's another element which is quite complex and which certainly becomes a lot more needing to be analyzed if the no effect threshold is reached only on some of the elements of the ecosystem, then it's the interaction and the change of behavior. Because an ecosystem is, by definition, a very complex system where the food chain, for example, is complex. And if you change one system, one element, then it will have over time an impact of the whole ecosystem. And this needs to be analyzed, and it's complex, and each case is different. I think if we hear Fukushima, imagine Fukushima on the Persian Gulf, it would be the magnitude of the environmental issue at the sea would be a lot worse than it is in Japan due to the high currents on the Pacific Ocean. So each case would be different. And I'm personally leading an expertise body. I think that what is needed is, in fact, is a combination of measurement and monitoring abilities, which sometimes don't always exist, a modeling toolbox which does not pretend to set one single value, because I think it would be a severe mistake to actually set a limit for exposure of any kind of biota, because there's all probability that these figures will be wrong in 95% of the cases. So I think setting limits, we see the limit of that even for humans. Why is it that in Fukushima, the doses to the population are a lot less than what is expected by the models, causing a lot of trouble in the population? So these limits, which are born only in the radiation protection doctrine and scientific community, suffer of a lack of connection to other elements which in fact affect the doses. So if you look at the environment, well, the change of behavior, the fact that some kind of animal resource will disappear will change the lifestyle for others. Maybe not for radiation reasons, but the others will maybe die because there is no more food. This is not radiation induced directly, but indirectly, yes. So I think all that has to be taken into account. So I would like to call for the scientific community for human exposure as well as environmental exposure. And that's what we try to do with our European platforms, Melody and others in Europe, is to bind together the scientific community, because effects of radiation have secondary effects which are nothing to do with radiation, but which are very real. And the society understands that more than the scientists do. They cannot explain. It's for the scientists to explain. So I would like to call ICRP and others to actually develop in the future more connection to other sciences which are very important to actually understand and lead a management of our environment on which the future of humankind depends, after all, in the most sensible way. Thank you very much. Now, this is, of course, I'm aware, a very complex and huge debate, and you have the floor. I think we have half an hour or so to discuss. So, who wants to speak? Okay, over there on the right. And please, you want to come?
Thank you, Doug Chambers. The environment's very complex. I have a question for anyone on the panel. In most situations in the real world, in addition to radioactivity, we also may have salinity changes, we may have temperature effects, we may have chemicals. This is true for nuclear power plants, it's true for uranium mines. And if you have a monitoring program, oh, I also forgot, we have natural variability with changes in temperature and changes in other things. So in an operational monitoring program, whether it's around a nuclear power plant or around a mine or some other facility, can someone comment on the challenges of actually finding a radiation-related effect in the midst of all this other stuff that's going on?
So who on the panel would like to address that? Yeah, Dr. Wibes? I think so, yes, you can speak from your seat.
One way is to cleverly design your monitoring. For example, you will look at an estuary, for example, and you will look at the salinity changes, the particulate fluxes, the interface between the salt water, the fresh water. You look at the species and how they interact in these environments, and you would measure the input of contaminants and radionuclide pollution in various places to select environments where you precisely have these manifestations of this complexity that you are talking about, and to try to discover the interplay between these things. So when you design a monitoring campaign, you're really just not a matter of taking samples at a few points blindly, but you really need to look for, and you need to use your oceanography and your radiology knowledge to inform the design of such campaign. And this is one example is what the Irish did in the Carlingford Lough estuary in 1990, where they precisely went there because they knew they had all these issues there, and they could make a detailed study of in that case, the speciation of the plutonium and the other radionuclides that were in there. And a lot of learning comes from this. It's looking for these scenarios where you can monitor properly.
Thank you very much. Other questions? So I see Abel on the first row, and then.
Okay. Can I ask Jody for the presentation and some questions? Actually, very general questions. That it's 2.5 years after the Fukushima, and another 20 years we have to learn a lot. But can you explain what are missing in the early phase of these 2.5 years? Which, if we have the data available, scientific data available, we might be able to adjust the issue in 2.5 months instead of 2.5 years. I mean that the impact is so big that no one can ignore it. And even today, NHK still the news about this leakage. But we are in the period of difficulties in the past 2.5 years. So what have been missing? And if we learn that, we might be able to take another challenge in the near future. Thank you.
My question is addressed to Catherine Hagley, because you are a member or vice chairman and Committee 5. How long time you need to get DCRL for all reps? Okay, the time span you plan. I believe you mentioned you will work forever. Okay, so I believe the concept of radiation protection, we are using it in a reversed way. Even before ICRP came to exist, I believe 1929 or 28. So we focus on human being only. And the dose limit was declined from this time up to now. And I believe it will go down up to natural background, which around 2.4 millisievert per year. But if we say from long time ago that we should protect not human being only, we should protect our biota. Okay, when we protect our biota, we protect the human being because they are living in our atmosphere. So, but now when we go and this trend with driving DCRL for all RAPs, I believe we need how many time? But when we reach these values, it may be our air, our water is polluted up to the limit, we cannot get it back. I need a comment about that. Thank you.
So I think there was first some answer from Dr. Bibes to the previous question. You would like to make a brief answer, Dr. Bibes? Just a minute. So let's please answer the question about the Dr. Bibes about Fukushima. Yes.
I'm really glad that you made this question because, well, first of all, a lot was achieved. The rapid response of the Japanese authorities and getting the fishermen to produce the samples and going there. So first of all, there's always things missing, but first of all, my point, a lot was achieved. But there's always something missing. And what I would have liked to see more is more matched sampling between seawater, sediment, and biota so that we could assess the external dose to biota better. I would have liked to see, as soon as possible, a follow-up of any observations on any effects that could be occurring in the marine biota, such that we could make an epidemiologic study of sorts, the equivalent on the biota, and see if it's, I don't know if even if it has been done, maybe it has, but I'm not sure. I would have liked to see, the focus was of course in iodine and cesium, and there were measurements of other isotopes, but I keep wondering where are there any transuranium elements in the local, very close to the plant? And there are things that, I don't know if is it because they weren't detected or because they were measured. And what else? Well, I would like to see more information about we talk about the interaction of radionuclides and other things that are happening in an environment. What bigger thing than a tsunami to happen? So what has been the effect of the tsunami and the changes in the coastal system in there? And can we understand a bit that? Because, for example, this has important implications for resuspension and remobilization of sediments that could alter the way in which radionuclides partition between water and column and sediment, and those kind of measurements I don't have. And finally, there are local hotspots that in any accident there have to be, and even now there are emissions that people are talking about, the potential leakages, to target these local hotspots to see if the effects that the doses that we're calculating for average organisms, but what are the most exposed organisms, and is there any detail? We could be missing some detail in the assessment because of the fact that we don't have that specific information. And these are the things lessons perhaps for the future. But let me conclude to say a lot was achieved, and if you look, when you get this on-scale report, you'll see it really is very comprehensive, and the databases that they produce. So hopefully that will give people a feeling that the assessment is solidly based.
Thank you very much. Dr. Heckley, do you want to answer briefly about the question which was raised about how long will it take to have all the data, and by then the environment will be completely polluted?
So I will provide some answer, and then I will ask my colleague, Dr. Copplestone, to weigh in as well. In terms of radiation sensitivity, I think that we have very good, broad understanding of the radiation sensitivity of a wide range of species in a general sense. But what we want to do is to be able to refine that understanding down to individual types of organisms. And as a scientist and as an academic, my goal is to be researching things forever. Okay, C5, probably not so much. And so I don't want to leave you with the idea that we have no knowledge of where adverse effects can occur. As I said, we have fairly broad brush understanding, and just as with humans, where we know at very high doses what it takes to kill people, we're trying to now get down into the very, very low levels and tease out what are some of the adverse effects that can occur at dose rates just above or in the realm of background. And that's something that takes quite a lot of effort to understand.
I'd like to add. The microphone's coming, I think. You have a mic? Speak.
I'd like to add as well that we have, if you remember and think back to the presentations that you've seen, we have a list of DCR hours for a range of species, range of wraps. Okay? So we have something which we can use as a reference to start building that framework. So I think we can already address the question. If we're not approaching the bottom of the DCR hours, you are in a position where you're not going to see effects of the environment. So as long as you're below the DCR hours,
Okay.
sorry. I don't know how much of that you call then, so very quickly. We have a range of DCR hours already available to us from the work that's been done up to now. Those DCR hours, if you're not approaching, if you're below the bottom of the DCRL band, there should be no effects in the environment. They've been set on a precautionary basis. So the bands in some cases are actually set below where we even see effects that we know about. We need to test and verify that and make sure that we have all the data we need to actually make sure that those bands are in the right place. A personal view, it is working, I don't know what's going on. A personal view, I actually think the DCRL bands should actually rise as we understand what's happening better in the effects. So that's a personal view about where the bands actually sit. But we will see. And I think the thing is, you mentioned about pollution in the environment, and I think that picks up on Doug's point a little bit about what are we doing when we have a mixture of effects and we see an ecosystem type effect? How can we distinguish whether it's a radiation effect or whether it's from some other chemical, etc.? And I think in those circumstances, as Geordie said, we need to go out and understand what the situation is, but we need to refer back to all the effects information we have and draw on the information from the chemicals risk assessment as well as what we're doing in radiation protection. And that will help us, hopefully, to start to understand what's causing the actual impact. And it may be salinity, or it may be temperature, it may be something we're not actually assessing, and we need to think about that. But I would hope that having something like the DCRLs already in place mean that we will not get to a situation where we've already contaminated the environment for radioactivity. We might for other things, but for radioactivity to a point where it's going to cause us problems.
Thank you. Abel, you had a question, but no microphone. Okay, it's coming.
The organization of this conference is brilliant and the food extraordinary, but the microphone very peculiar. Well, you know, when we talk about topics like environment and radiation, it's very easy to start to open the scope, and I would like, with your permission, Chairman, to go back to the purpose of this symposium, that is the system of radiological protection and how it works. Now, we saw the first application of the system to a concrete problem that has a lot of political importance, the London Convention, the London Dumping Convention. Now, my question would be the following. The system seems to have worked well. in solving the problem. Why we want to continue to research on this system if the system is working well? I mean, what is the objective to continue to refine the system? This is my concrete question to the panelists.
Maybe I would like to answer, and then you can complement. And I think it's true for the whole radiation protection system, also for humans. The system works very well as long as we remain in a no effects. I'm not talking about individual accidents of severe exposure, but when there are lots of people, lots of complex environment ecosystems are concerned, the radiological approach of ICRP is very clever. It's based on science, and it helps demonstrate in advance or afterwards to check that the no effects goal is actually reached. Okay, so there are still questions, but basically I would tend to agree with you. The problem is that if something like Fukushima happens, the same system then suddenly becomes incapable of telling a story to the public of what are the doses, real doses. How do you construct that? So the protection of ecosystems, once you start seeing elements disappearing after an accident, what are the good remediation possibilities for ecosystems? And there I see a point in being able to do dosimetry in a particular fish, because we need, this is a scientific toolbox. So I think there should be a difference between the science toolbox, which needs to be incremented all the time. I agree with you that we need, science should never stop, because if it stops, then you have no more scientists, and then it's dangerous. But we should have a more and more elaborate toolbox, and we should have experts or expert systems, international expert bodies, so that no individual expert or organization is told that they are biased, etc., but they should be on the IAEA or other people like that. Collective should be able to get together and provide a story for society and solutions for governments, whoever who want to take remediation situation. You see, for example, our friends from Korea, they don't want to buy Japanese fish. There is no reason for that. But the communication from Japan, from Fukushima, is such that it allows this kind of things to happen, which is very damageable to the Japanese economy, but also worldwide, because it conveys the wrong image about the nuclear accident consequences. And so I see there something missing, and I think the ICRP has a role to try and complement that, and that can only be based on further science. And this, again, I think it's also for human exposure as well as ecosystem. But on the dumping convention, and I think it's a very good example.
Please don't misunderstand me. Of course, I'm a fanatic of good science, and that science has to continue. But perhaps a more simple message for Fukushima would be that although the release has been enormous, and we should not applaud this type of releases into the ocean, still, the release of Fukushima is just a mosquito in comparison with the release of the weapons testing into the sea. Weapon testing, according to ASCARI, have released into the sea thousands of exabecquerels. Well, Fukushima is a fraction of that. Maybe that would be more understandable to the people than other things. But nevertheless, please don't misunderstand me. I applaud the continuation of science to know better and better and better and better what we know in all fields of science. But which I wanted to know whether the system of radiological protection in the moment like it is working or not.
So a brief answer, and then I think you wanted, but first, please, is your mic working? Yes.
Okay, sorry.
Yeah, I want to be, it's working?
Now? Yes, okay. I will repeat a bit, but we are one of the main users of the ICRP because the agency, based on the ICRP, develop international guidance and international standards. This is in our mandate. we have developed international guidance, and it's approved. It is in a convention, it is tested, and it works. We are incorporating in IA safety standards for plant control releases a similar approach to assess the impact to flora and fauna from normal discharges. And we know that it works. So I think we should be very clear with this message. The system developed by the ICRP works for normal discharges. And there is no indication. There is no indication that there is impact for normal discharges. You will hear the impact is the temperature, it's not the radioactivity. So we have to be very different what is an emergency or an existing situation than normal, but we should recognize that for normal the system works. When the ICRP talk about science, I agree, science is important and we foster the development of science, but I think first we should discuss what for and which data you will use. If you don't have data, it's not science, maybe it's just modeling. But if you not can compare with effects, what's the science? And then what for? What do you need to improve? And probably what you need to improve is something very simple. It's how to map species different to the RAPs to see if the system works for these strange species, if there are. This is one work the ICRP should do. The other thing the ICRP, I think, should do is to how to define the impact at the level of populations for existing an emergency, not for plant exposure situation. You don't need that. So I think the ICRP work should be focused on what is missing and let the part of the system which works be applied by the international community. And if these discussions go on and on, we will be discussing again 10 years more until we have the standards for all the situations. So I think that we should start using this approach for normal discharges and recognize that it's a good tool for controlling discharges and for assessing the impact.
Thank you very much. I think we have time for a last question from Professor Niwa.
This is not a question,
Or a
but
remark.
a comment. And I really agree with Abel on that concern, but at the same time, I noticed back in Fukushima, very interesting situation on this environmental issue. That is, a Tokyo University professor been studying the level of cesium in rice puddle, coming from 2 rice puddles, just side by side. And one is giving, same soil cesium concentration. And one is giving high concentration of cesium in rice, the other one is not. And he was scratching, and finally he came up to the conclusion that this one is irrigated by still water. This one is irrigated by running water. During summertime, the still water puddle with higher temperature, with higher activity of bacteria and everything, is somehow mobilizing the bound cesium into the system so that rice is absorbing it. And then I found that this environmental side of radiation ecology, radiation ecology has a lot to do with the community management of rice puddle. And I never thought that this environmental radiation biology can have any much impact, but there is a strong connection depending on where you are and so forth. So I'm not really saying not much of the ICRP system or anything, but we really have to be aware that there is a strong connection of this environmental radiation with our own society. So this is a kind of aspect we have to somehow, maybe one of these days, have to put into this system so that we can have wider field of research to study on this radiation issue of the environment. That's my comment.
Thank you very much. I think we are reaching the end of our discussion session.